Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to continue our series on balancing redox reactions by the method of half reactions. But in this video, we're going to do it in a basic solution. So we're going to have to do all these 7 steps and the note that's on the bottom. Okay, if you missed on how to do these first 7 steps, okay, that was in the previous video on how to balance this reaction in an acidic solution. So a basic solution is the same 7 steps as the previous video, but with the addition of the note at the bottom. Okay, so let's get right into this problem. We're going to start with step 1 by writing 2 incomplete half reactions, and that's going to be a side that's for carbon and then a side that is for the manganese. Okay, so I'm going to go ahead and do the carbon side first. So we're going to do the Cn minus yielding the CnO minus. And on this side, it's going to be the manganese. So MnO4 minus yielding MnO2. Okay, so the first step is just to split things in half to create the incomplete half reactions, and then the second step is to balance all the elements other than oxygen and hydrogen first. Well, it looks like the carbon and nitrogen are balanced, so there's really nothing to do in step 2. The manganese is also balanced, so there's nothing to do here as well. Try that again. MnO2. Sorry for the chicken scratching there. Okay. All right. So step 2 is the same because the manganese are balanced, the carbons are balanced, the nitrogens are balanced. Now we get to balance the oxygens by adding water molecules. Well, the oxygens aren't balanced here, so we're going to have to add a water molecule on the right-hand side. So we're going to add this water molecule here. And we did that so that the oxygens would balance out. So I'm going to underline this because that's what I did in step 3. Okay. Over here, I got 4 oxygens and 2 oxygens. So I need 2 more oxygens over here. So that's going to be 2 water molecules on the right-hand side. And here are the 2 water molecules on the right-hand side. So now I have 4 oxygens on both sides. Okay. Step 4 is now going to balance the hydrogens by adding protons. Because I added these water molecules here, the hydrogens are not balanced. So I'm going to have to add some protons on the right-hand side. And I got 2 hydrogens here, so that means it's going to be 2 protons that are going to have to be added on the right-hand side. Over here, okay, I have 4 hydrogens, so I'm going to need 4 protons on this side in order to balance out the hydrogens. I'm going to underline that as my new step. And everything else is going to stay the same. So 4 hydrogens, 4 hydrogens, okay? And here comes step 5. This is the one that I circled last time because this is the one that usually gets students. You got to balance the charge by adding electrons. So let's take a look at the charge, okay? On the left-hand side, okay, I have one thing that's neutral and one thing that's a -1. So that's a -1 charge. And then on the right-hand side, I have one thing that's -1 and 2 things that's a +1. So we get a +1 charge on this side. So I'm going to have to add 2 electrons to the right-hand side in order to have this work out in step 5. So we will end up getting something that looks like this. So those 2 electrons with the +1 will make it equal a -1 on both sides of this equation. Okay. And then for the right-hand side over here with the manganese, I got 4 +1s and 1 negative 1. So that's kind of like a positive 3 as far as charge on the left-hand side. I got 1 thing that's neutral and 2 thing that's neutral. So that's going to be just neutral on the right-hand side. Okay, so for this problem, I'm going to have to add 3 electrons to the left-hand side to make this side neutral and therefore be neutral on both sides. So let's go ahead and add in our 3 electrons. And this is kind of what we will end up getting. And then we go to step 6, okay, which is multiplying each side so that the electrons are equal to each other. So I got 2 electrons versus 3 electrons, so I have to multiply this side by 3 and this side by 2 in step 6. So 3 waters, 3 CNs, 3 CNOs, and 3 times 2 is going to be 6 protons, and 3 times 2 is going to be 6 electrons. So this is what I had to do with each of those problems. I'm multiplying this side by 2, so 6 electrons. 4 times 2 is 8 protons. 2 times 1 is going to be 2 MnO4s. 2 MnO2s. 2 times 2 is going to be 4 waters. And we got through step 6. Step 7 is add the reactions together. So I'm putting all the reactants together on one side, okay, and that's going to end up being equal to 3H2O, 3Cn minus, just 2 items, okay. Got 3 items here, 6 electrons, 8 protons, and the 2 MnO4 minus, okay? Now on the right-hand side, we put all the products, so 3 CNO minus, 6 protons, 6 electrons, and then the 2 items over here, which is 2 MnO2 and 4 H2O. Okay, so we have everything added together. Okay, and now we got to cross out like terms, and there's lots of things to cancel out this time. So the first item is the 6 electrons. They are canceled on both sides. Now we look at the protons. We got 6 on this side, we got 8 on this side. So all of these 6 are gone, and now we're down to just 2 protons on the left-hand side. Same thing for waters. We got 3 waters on this side and 4 on this side. So all 3 of these are gone, and we have just 1 water on this side, okay? Now, if this was an acidic solution, this would be the end of the problem, okay? However, it's a basic solution. So if it's a basic solution, you must add hydroxides to both sides in order to neutralize the protons, because protons are acidic, okay? So we need to get rid of them, and we do that by adding hydroxides. So here are the 2 protons. So if I add 2 hydroxides to this side, sorry, there's 2 hydroxides, I'm going to have to add 2 hydroxides to this side. Same thing that you do in math class, okay? Now, these 2 protons and 2 hydroxides are going to combine and form 2 waters. And we got some more things to cancel out now because we have waters on both sides, okay? So you continue your canceling out. So this 1 water is going to cancel out 1 of these waters. So there's only 1 water on the left-hand side remaining. And now to clean all this up, let's put everything together. We got 3 Cn minus, okay, plus the water, plus the 2 MnO4 minus, and that's going to yield 3 CNO minus, those 2 hydroxides, and the 2 MnO2. This is your complete answer, And as you can see, it's no longer an acidic solution. There's no protons present. In fact, you see the basic stuff by seeing these hydroxide ions. And this is how you solve the problem for balancing this equation through the method of half reactions. If you found this content helpful, please give it a like and subscribe. And when you add that comment, it really does push this information to other students that are interested in learning chemistry.